Okay, so for today, first off, a polynomial. Have you ever heard of mono? Do you know what mono means? If you just talk, not the sickness. One. How about bi? Two. All right, so if I said I had a binomial, it would mean I would have two terms. It would be like y equals x squared plus 6. That's a binomial because it's got two terms. What if I made it x squared plus 6x plus 5? Then it's not a binomial anymore. What is it now? Trinomial. Anytime you have any number, the general word for that is polynomial. Any number. So even one term, like let's just say it was just y equals 3x to the fifth. That is called a polynomial, even though it's also a monomial. Let me make sure you understand why. Because imagine for a moment it was a shape. Do you get if I have an octagon and a decagon? Those are all different kind of polygons, right? Get what I'm saying? Even if they have a very small number of sides, what is the smallest number of sides a polygon could have? Three-sided, the triangle, okay? There's no such thing as a biangle, all right? All right, there should be, all right. Okay, so I need to teach you all about polynomials, and the graphs are going to look different. Instead of just things like this, like they were last chapter, which would be like, you know, quadratics. We had a ton of things with quadratics. That's why we're using the quadratic formula, left and right. We were finding that line that runs down the middle called the axis of symmetry. We're done with those. We're moving up. And the graphs that we have now, they're going to look more like this. They got an extra turn in there. And that's like x to the third. All right, so here is a whole bunch of little things that you need to know. All right, I'm going to pause for just a second. Okay, so typical problem for today looks like this. Y equals 6x squared plus 4x to the fifth plus 4. Now, just to clarify, do you get that this is the biggest degree here? This 4x to the fifth? Aren't those usually first? Usually they are, but they don't have to be. The one that has the biggest power is the winner. It's the boss. It's got the lead coefficient that you're going to care about, but it's not in front. It's not always in front. If you were the general, biggest power, get it? If you were the general, could you stand anywhere you want to in line? Well, yeah, you could be like, in this picture, I'm going to be in the middle. And you're like, yes, sir, because you're the boss. So sometimes you got to note it's not always the lead. People think the lead one is always the first one, and they'll look here and they'll go, well, the lead number is 6. No, it's not. The lead number is actually 4. It's the one that's on the biggest power. Okay. Do you get that there are 3 separate chunks here? Is each chunk? Each chunk is called a term. There's 1, 2, 3 terms on this one. This one's considered the lead term, not because it's in front, because it has the biggest power. And that lead term tells you lots of really important stuff. Now, if you saw this quadratic, x squared plus 6, and it was negative, I know you know that that'd be an upside down parabola that's shifted up 6, and it would look kind of like that. Do you get how I can look at that and then know it looks like that just in a few seconds? Well, I can look at this and know what it is. You can't, but that's what I'm going to try to teach you today. So I can look at this and you can look at that, and we both know it looks like this. I'm going to try to give you a quick, like, oh, I kind of know what that looks like, just from some rules. So here are those rules. The thing that tells you the right end of the graph. Take notes on this. Write this down. The right end comes from the lead coefficient. The number in the front of the lead term. If that is positive, if lead coefficient is positive, then the right end is up. If the lead coefficient is negative, then the right end is, take a wild guess, down. There's going to be several things. You need to write these down. You will not remember all of them. You might remember a few of them, but if you write them down, you will be able to remember them. And then tonight when you're working on your homework and you're putting in the few problems that I'm going to ask you to do, it's a very doable assignment. But if you're at home and you're like, dang it, I can't remember what that lead coefficient tells me again. If it's positive, then the right end is up. If it's negative, it's down. Well, take a look at this one. They're all plus signs, so it's pretty easy. That's positive. So the right end is up, which means if I look at the graph, here, I'll move over to this graph over here. See how it's up on the right end? It'll be going up like that. Let's do another one. Y equals negative 6x to the 8th plus 2x plus 6. That negative right there tells me that the right end is doing what? Going down. So if I had to make a sketch of it, I know it ends going down. It's kind of like a story that has a sad ending. Where the red fern grows. Old Yeller. Hope that's not a spoiler for anybody. Anyway. All right. So if it's negative, it's going down. What if it's positive? It's going up. Notice it only tells us the right side. So I know that looking at this graph, I know several things. I haven't told you everything yet, but I told you this part. It's going down on the right. It's got a y-intercept. I bet you can finish this sentence. The y-intercept is where x equals 0. So if x equals 0, that's gone, and y equals what? Has to go through 6. So you know what's in the middle of the graph, and then how about if you knew if the other end went up or down? You know how I can tell?
Because it's the opposite of where...
All right, here's how I can tell. The boss term is even, so the left side will be the same. If this power is even, the left end is the same. Take a wild guess what I'm going to write for odd. Opposite. Okay, so you got to look at the boss term, the lead term. If it is an even number, then you'll both be going the same direction. If the right end was up, the other end will be up. But if it's odd, it'll be different. And odd and different kind of go together. If I said that my car was pink with white polka dots, you'd be like, huh, that's kind of odd. Or that's kind of different. Okay? So, even kind of also makes sense to be like the same. If I said both ends of that board are even with each other, I think you'd be like, oh, I know what you mean. They're kind of the same. They're both the same height. Okay. Anyway. All right. That's the y-intercept. And now you know almost everything. We're almost done. One thing you don't know is what's happening in the middle. I know this goes through 6. I know that since it's even, they're both going the same direction, so it's got to be going down on both ends. But what's it doing in here? Like, is it going up and down and stuff? Yeah, it probably is. So here's how you decide how many little loops it's got. I'm going to give you a couple that you know, and you'll see how many loops they have. Y equals x squared. I know that's positive in the front. So it's going up on the right. We never talked about it that way before, but now that you need to know about the bigger powers, you can say, oh, it's positive in the front, so it's going up on the right. It's an even power, so they're both going in the same direction. So it's got to be going up on both ends. The y-intercept is where x equals 0, so this one has a 0 at the end, so when you put a 0 here, y equals 0. Oh my gosh, it goes like that. Get the idea? That's one you would have known in the first place, I know. So here's another one that you wouldn't know. Before you walked in, you wouldn't have known what this would look like at all. Now you know the beginning and the middle and the end. And then I'm going to tell you what happens in between. Sketch it. You should know how it ends. Is this like the red fern grows where it's kind of going down, depressing at the end? Yeah, it is. And this is odd. What does that tell me, sir? Good. So it must be going up on this end. And then exactly in the middle is the y-intercept. It's a y-intercept.
8.
Good. It has to be going through 8. Now, what's it doing in between? If it's power of 7, pay attention, there are 6 turns that are possible. Watch. That's a turn, that's 1 turn. I'm going to go through this 2 turns. So that was a turn, that was a turn. 3 turns. 4 turns. There could have been as many as 6 turns, but there could not have been 7. Now, do you know exactly where all of those turns are? No. And even somebody who is a genius in math wouldn't be able to tell you where all of those turns are just with their head. They'd have to use a calculator. Now, you could probably get close, if you're pretty good at math, to knowing, I kind of know about where that is, but exactly what point is that right there? Not without using a calculator. Or maybe, I guess there are some old devices that used to work. Have you guys ever heard of a slide rule? All right, that's like really old tech. It was a stick that they just wrote numbers on in just the right places, and they'd slide the stick so that some number matched up with other numbers, and you could do some kind of cool calculations with those. But anyway, you'd need some sort of calculating device. So that 7 does not tell you exactly what's happening, but it tells me at most there were 6 turns. Did I make 6? No. 1, 2, 3, 4. I made 4 turns. Could I have made 5 turns?
No. 'Cause
Why no? You're right, but why no?
then that would be going against your negative 6x to the 7.
So if I would have made 1 more turn, I'd have been going up on both ends.
And then that would be against
And that would have been against the rules. Because this said they should be going opposite directions. And this said that it should be going down on the right. So I could not have done that number. But I could have done 6 turns. The 6th turn would have put us back on track. We're going down again. We're doing the opposite of this one. And okay, so let's see if you've caught it. Here's the final answer, or final one. That's normal. Negative 6x squared. No, yep. Plus 8x to the 3rd minus 2. All right. So first I'd say, how does it start? No, actually it's best to know how the story ends. I just actually read an article by a guy who said he likes to know how the story ends in movies. He won't watch a movie unless he knows how the story ends. Like, that would drive me crazy. I don't want to know how the story ends. I like to be surprised. But there's a lot of people, apparently, he says that there's whole websites full of people who go on purpose to watch the spoilers before they go to a movie so they know how it ends.
One of my friends does that.
Really? Yeah, it seems so weird to me. It's like if somebody tells me.
Summary of like the entire book or like the movie or something.
Yeah.
And then she's like, "Oh, this is a sad ending," and we're all like, "Don't tell us."
I know. I hate it when people spoil the ending. But, all right, so in this case, though, we know it's a negative. It's going down. Did you know it was going down on the right? All right. Then what about? Oh, we got fooled. Because why? The boss is not the negative 6x squared. What's more powerful? The 8x to the 3rd. So the lead coefficient isn't that negative 6. It's this positive 8. That's the lead term. This is the lead coefficient. Is there a difference? Yeah. We The lead term is the whole thing. The lead coefficient is just the number that's in the front. All right, so now that I know I'm looking at that one, it's positive, so it's going up on the right. The y-intercept is -2. And it's odd, and that's different. So what does that tell me about the left side? Gotta be going down. Now, how many turns can I have?
2.
If this is a 3, then I can have 2 turns. Watch. 1 turn. 2 turns. We describe a turn as not just like a small course correction, but if you ever go from going down to going up, that's a turn. Or from going up to going down, that's a turn. So that's a turn, that's a turn. This little thing in here, that was a little waver, that's not a turn. It has to change direction and go from down to up or vice versa. Okay, so this had 2 turns. Degree 3, coincidence? I think not. It's always going to be 1 less than whatever the degree was. All right, so the questions they could ask you are, what's the degree? And you would have said 3. Don't try to add them up. It's just the biggest one. They could have asked you, what's the lead term? And you would have said 8x to the third. They could have said, what's the lead coefficient? You would have said 8. They could have said, what's the y-intercept? You would have said -2. And how many turns?
2.
1 less than that. So yeah, since that's a 3, 2. Okay, there it is. Now, that's normal ones. Here's one that's written strange and it threw everybody off last hour, so let me tell you ahead. They asked, what's the lead term on this? A lot of people said 2x.
No, you just factor, or you have to.
You factor in that last one, and you're right. If you multiplied it out. Now, you're right, and that's what one of the smart kids last hour did. They multiplied the whole thing out. But all they need is the lead term. You can shortcut. Imagine you multiplied it all the way out. Till you get it would be a 2x to the third.
Yeah.
Because that 2 times that x makes 2x. And you'd times by this x squared. And you get 2x to the third. That's the lead term. All right, so here's one like that. Last one, and it's the last weird one. Let's say I had y equals 3 parentheses 2x plus 1 parentheses x plus 3 squared. Here are the things they could ask you. What is the lead term? What's the lead coefficient? That's the number on it. What would the right end do, like up or down? What would the left end do? Think about it, how it's the same or it's different. And that is coming from the power. All right, bring your phone, set it up on my desk, and that's totally not okay. I'm getting really tired of taking your phone away, and don't tell me you're trying to get me a bat belt, because I don't think that's what it is. All right. So, try to answer these 1, 2, 3, 4 questions, and then there's one more. Oh, y-intercept. I'll pause for a second while you give this a try. All right, bounce around to different people here and see who knows what. Dice of Destiny. It is row 1, person 2. That would be you back there, Mr. SB. Number 1, lead term. It feels like you're just doing it now. Okay, I'm going to give you a chance. I'm going to come back to you later. Go at light speed and try to answer a bunch because I'm not going to ask you the first one. All right, different person. Row 3, person 3. That's you. Yep. And you got that because you went that times that to the that. And that is 6x to the third is correct. How many of you had 6x to the third? That's a lot of you. Good job. Okay, next one. Row 3, person 4. PH, that's you. Yes, the coefficient is just the number that's on that lead term. That tells us something. Row 2, person 2, that's you, up on the right. How did you know that? Because the lead coefficient was positive, it goes up on the right. Now on the left end, it will not tell you that it's up or down. It'll just tell you if it's the same or different than the right end. Row 5, 2, 3, 4, person 1, that's you. Yes, you. The left end, I'll give you a hint if you need it. But the question is, what tells you whether it's up or down? And it's this little power right here. I'm going to walk you through it. Is that even or odd? Does that sound like the same or different? And therefore it should be different, and therefore it should be down is correct. Okay, and then last person. This is row 6, person 4. That's you, Mr. SW. The y-intercept is interesting. You might be right. I'm going to double check it. Fill in this sentence for me. The y-intercept is where what? X equals 0. So I'm going to put in a 0 wherever there's an x. 0 goes here. 0 goes here. And this part is 1 times 3 is 3 times 3 squared. The 3 squared will have to happen first. That's 9. 9 times 3, 27. That was a tough one. Do you get how I did that, though? It's not just the last number. It's the y-intercept is where, finish that sentence? X equals 0. So you stick a 0 in and you figure it out. Okay. And then if I had to sketch this, watch how fast it is. Once you know all those things, I know it ends going up. The left end is down. It has to hit y-intercept of 27, which is like way up there. And I happen to remember that since it's got a 3 here, it could have at most 2 turns. 1 turn, 2 turns, there we go. And could that be right? Nope. What part did I mess up? Y-intercept. I didn't go through the y-intercept, so I got to try again. 1 turn, 2 turns. Could that possibly be right? Yes, it's going through the y-intercept. It's going up on the right, down on the left. And it's got the right number of turns, 2 turns, where this has a degree of 3. There, you know everything. All right. I do like to show people where we're headed. The only thing I'm going to show you is if we can factor it, and we get something like this, then we could tell exactly where it hits on these roots. We might know that, oh, look at this. It's hitting right here because I got it factored, and I can tell that it's hitting at -3. You're going to learn that part next. But at least you know how many turns it's got, you know what the right end and the left end are doing, and you know the y-intercept. But you don't know exactly where these spots are yet, and you'll do that by factoring. By the end of this unit, you guys will be master factorers. All right. And that is all I have for you for the video for today. This homework is a Schoology quiz. Go ahead and get started on that now.